Hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's see today's problem, smallest number. So what the problem is saying is we will be given two numbers S, okay. S, for example, S is sum, right? And we'll be given the number of digits 2, for example. So what we want to do is we want to find out, okay, we want to find out the smallest number whose sum will be equal to this given sum, and who the number of digits will be equal to the this according to the D. Okay, so for example, here D is 2, right? So there'll be two positions. We want a number with two digits, okay? And what we want? The sum, right? So what can be the possible integers? Okay, so this will be the integer. For example, here, right? 7, then 2, right? Then here 6 and here 3, then 5 and 4, right? 6, oh sorry, 4 and 5 and so on. Okay, so these are the few integers whose sum is equal to 9 and the number of digits are 2. Okay, and what we want to do is we want to return the smallest number out of all the possible integers. So here in this case the smallest number is 18, okay, whose sum is equal to 9 and the number of digits is 2. Okay, now let's take another example. Let's take another example. For example, S equal to 18. The expected sum is 18 and D equal to 3. So in this case, what will be the smallest number? So the smallest number will be 9, 8 and 1. That is 189. 189. If you see 1 plus 8, 9, 9 plus 9 equal to 18. Okay, and the number of digits is 3. So you can check, like, this will be the smallest number definitely. Okay, so this is what you want to do. This is what the problem has asked. Okay, let's take another example where the answer it is not possible. For example, S equal to 29 and digit equal to 3. So if we take three positions, right? Even if we take the maximum 999, the number, right? 999 number. What will be the sum of the digits? It is going to be 27, which is lesser than the expected sum, right? So the answer is not possible in this case. So we'll return -1 in this case. Okay. We'll return -1 in this case. Okay. So how can we solve the problem? I hope you have got this. You have got the ask. What is the ask? Now let's see. Let's take an example. Okay. What we'll do is we will take D equal to 6. Okay. D equal to 6. So how can we solve the problem? Okay. For example, if there are 6 positions, right? The expected digits are 6. So what we'll do is, what we'll do if we'll check if sum is greater than 9 or not. Yes, if it is 9, if it is greater than 9, then we'll place a 9 over here at the least significant bit. Okay, and we will deduct this 9 from the sum. Okay, and the remaining sum will be 9 here, right? And the remaining sum will be 9 here. So now for this position, we'll check if the sum, if it is greater than 9. No, it is not greater than 9. Then in this case, what we're going to do is we will reduce this sum by 1. Okay, S equal to 9 minus 1. Okay, 8. Okay, just be with me, you'll understand why you're doing this. Okay, so we'll place 8 over here. We'll place 8 over here. Okay, okay, we'll place 8 over here. And for the remaining ones, right? For the remaining positions, till the second position, we'll insert zeros. Okay, we'll insert zeros, and at the end, for the most significant bit, we are going to place 1 over here. Okay, we are going to place 1 over here. So if you see 10089, if you see what is the sum of this, 1 plus 8, 9, 9 plus 9, 18. Okay, which is expected sum, and also the number of digits is 6. Okay, and this is also going to be the smallest number. Okay, this is also going to, so this will be the intuition behind the solving the problem. Okay, we can take another example. S equal to, for example, 12. The expected sum is 12 and D equal to 2. So in this case, what we are going to do? First, we'll check whether sum is greater than 9. Yes, it is greater than 9. We'll place 9 over here at the least significant bit. We'll deduct 9 from 12, which will have remainder 3, right? We'll have remainder 3. Now, since we have only one position left, so we won't do the operation what we did here, right? We deducted 1, we placed 8 over here, we placed zeros, and then finally 1. Okay, since only one position, that is the most significant bit is left, we will place our answer as is. Whatever is the sum, whatever is the remaining sum, we'll place as is. 39. Okay, so this is going to be, okay, so this is going to be the smallest number here, 39, which is 12, whose sum of digits, whose number of digits is 2. Okay, so this is the intuition behind solving the problem. I hope you have got the intuition. Before going to the code, I'll request you to subscribe to my channel, as a lot of effort goes in creating these videos. Okay, thank you so much. Let's go to the code now. First, I'll show the Java code followed by C++. Okay, so what we'll do here is we'll take an answer variable. We'll initialize with empty string. Okay, and what we'll do, we'll run our for loop int I equal to D minus 1. Okay, as we were starting with this, right? With the least significant bit, right? That is why I equal to D minus 1. Okay. I greater than equal to 0. Sorry. I minus minus. Okay. So now what we'll check? If S is greater than 9, then in this case, what we're going to do? Answer equal to 9 plus answer. Okay. Okay. And also we'll deduct 9 from the sum as we did here, right? As we did here, right? We did here, right? 18 minus 9 we did. Okay. If it is, if sum is not greater than 9, then there are two cases. Okay. Then there are two cases here. So for example, if I equal to 0, right? That is, I had told you, right? For this particular case, I was 0 here, right? I equal to 0. So in this case, we will use the sum as is, whatever is the sum, plus answer. Okay. Here we'll have to do integer dot toString, right? As is a number, to convert into string. So sum plus answer. Okay. And what we'll do? Okay, that's it. Okay, for this and for example, if I is not 0, then what we're going to do? We are going to do this step. We are going to do this step. This one. 9 minus 1. So what we'll do? S equal to S minus 1. Okay. We'll place this sum integer dot toString, whatever year it was, right? We'll copy paste this. So what we're doing here? So here 9 was remaining, right? What we did, we deducted 1 from the sum, which is 8. And now we are placing this 8 over here in this particular position, right? We are placing this 8 in this particular, that's what we are doing here. Okay, that's what we are doing here. Okay, so once we have placed, for example, this particular 8, right? This particular 8, okay, this particular 8 into this position, okay, we will reduce our I. Okay, we'll reduce our I. Okay, I minus minus. Now what we'll do? While I is greater than 0, okay, we want to leave till these, right? Till these positions, excluding this one, right? So what we'll do is we will we will add 0 answer, right? And also we'll do I minus minus. Okay. So so this will run till I equal to 1. Okay. If it is I equal to 0, it will break. And what we are going to do is we are going to add what? 1 to the answer. We are going to add 1 to the answer. Okay. Okay. We are going to add 1 to the answer and we'll simply break. Okay. And what we are going to do here? Now return answer. And one more condition we have not covered is if, I'd explain this, right? If the maximum sum, right? If it is still lesser than the expected sum, right? Then we are going to return simply -1. So that's what we saw here, right? In this particular case. So this particular case, S equal to was 29, right? And D was equal to 3, right? So this, right? 9, 9 and 9. 9 into 3, right? 9 into 3. 9 into D. Whatever is 9 into D, right? So what is the sum here? 27, which is lesser than sum. So the integer is not possible. So that's what we are returning -1 here. Okay. So let me compile this. I hope this should run. And yeah, I need to place a break over here, right? We need break for this as well. Okay. So let's compile again. Okay, let me submit this. Okay, the test cases seem to pass. Okay, they have passed. Thanks for watching. I hope you've got the solution. Please subscribe to my channel, like the video. Also, let's quickly see the C++ code. It's almost same. No, not much difference. Okay. So here is a C++ code. So if the sum is not possible, we'll return -1. We have taken the string answer. Okay. And that's what we are doing here. Whatever we did in the Java as well. Okay. Only difference is to converting integer to string, we are using toString here. Okay. Rest everything is same. Okay. I'll also attach this code in the comment section. Okay. Thanks for watching. Okay. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.